Okay, section 3.3. We're going to wait on the change of base formula. So this first learning target, we're going to wait till section 3.4. That's when we'll use it more anyways. We're really just going to focus on these next two. I can use properties of logs to evaluate or rewrite log expressions. And sometimes we'll be able to evaluate some common logs or common calculations. And we can also use properties of logs to expand or condense logarithmic expressions. Okay, so what properties of logs are they talking about? They're right down here at the bottom of the page. Properties of logs. Okay, the product property states this. If I have u times v or any type of product inside the argument, I can split this into a sum of logarithms. Okay, no matter what the base is, it works. Okay, even if it's base e, they even put the natural logarithm version of this over here, but we don't even need this. This summarizes everything with any base. Base 10, base e, base 2. It works. Okay, so this, if that confuses you, you can even cross that part out. It doesn't matter. This summarizes it all. There's something called the quotient property, meaning if in the argument we have a quotient or fraction form, we can expand it and write it as 2 logs as the difference of the 2 logs. Okay, so one is sum. You got to link product to a sum and quotient to a difference of 2 logs. Okay. And then the power property states just this. If I have an exponent here in the argument, I can actually write that as a coefficient right there. Some students like to see it like this too. N kind of comes out front. And we write it as n times log base a of u. Okay. All right, so let's look at the directions for 4, 5, and 6. Use these properties of logs to write the logarithm in terms of log base 3/8 and log base 3/11. All right, well, they gave us 2 numbers that we could kind of work with. 5, they already are written as an 8 and 11, okay? But this one, we just got to use a little bit of creativity to kind of rewrite that. So I can write this as log base 3 of 8 times 11 to get to that 88. Okay, and they kind of want us to expand it because they want us to get to just log base 3 and log base 3 of 8 and log base 3 of 11. So right now I have a product. So if I have a product of 2 things, I can write that as a sum of the 2 logs and break it up into 2. So we're going to say this is equal to log base 3 of 8 plus log base 3 of 11. This looks a little familiar from these properties from Algebra 2. Something that you probably covered. Okay, so that's kind of the u times v thing that they're saying up there. So log of u plus log of v. All right, and sometimes you can evaluate these. Like if this was log base 3, let's pretend for a moment this was a 9. Well, log base 3 of 9, that worksheet, we're working on stuff like that. 3 to the what power gives me 9? It'd be 2. So I'll replace that with 2. That'll happen on some of them on the next page. So start getting used to looking for that. All right, but we actually took care of the directions. It did say to write them in terms of these 2, and we did. So there's the answer. Okay. Let's take a look at 5. Now we have the opportunity to use the quotient property. I have a u over v, so it's log of u minus the log of v. So I'm going to write this as log base 3 of 8 minus log base 3 of 11. And there's nothing else we can do. By nothing else we can do, sometimes you might have the power property. Like maybe I've got like an 8 squared here, and I can bring the 2 out front as a coefficient. I can't do that on this problem, so that's it. Okay. Number 6. Let me give you a moment to kind of think this one through, but there is a way we can rewrite 121 with an 11 or an 8, and there is a way we can rewrite 64 with an 11 or an 8. So try to rewrite those first, and then see if you can use some of these properties to expand it a little bit, okay? I'll give you a minute to get ahead of me, pause, and try it. All right, so we can write 121, 11 squared, 64, a squared. Now just use the quotient rule, u over v. So then log of u minus log of v. Okay. One last thing we can add to this one is that power property. I've got these exponents that can be written as coefficients. So it's 2 times log base 3 of 11 minus, oops, I forgot to squeeze the 2 in there, minus 2 times log base 3 of 8. And the directions didn't really say expand it as far as you can. They will on the next page, and it'll be clear that you need to keep going here. All right, so that's the final answer to this one. Okay, not a lot of application properties in this section. We're going to use these properties in 3.4, and then you'll see the applications of what we can do with these properties. Okay. All right, go ahead and turn the page. Okay, for these problems, we're going to work on evaluating these a little bit and using our properties. You don't really have to state the reason. That's not going to, if you can't do it, you're just not going to do it. Okay, so remember this property for exponentials here. I'll rewrite it. I'll rewrite it up top. It's something we covered at the beginning of chapter 3. Okay, if it's in radical form, how do we convert it to exponential form? The root goes in the denominator. Okay, so whenever you have a radical in this section, you're going to want to put it in exponential form, because if it's an exponential form, we can do something with those exponents called the power property. Okay, so let's do that first for number 7. Let's write this as log base 3 of 27. How do I convert that to an exponent? Remember, this is it's 1 in there if it's not there, and then the root is 4. So I can write that as 27 to the 1/4. Okay, just like square root to the 1/2, fourth root to the 1/4. Okay. All right, and now I can use the power property to bring that out front. So I'm going to say 1/4 log base 3 of 27. All right, the directions are indicating that we might be able to find the exact value of some of these expressions by doing what we did on the worksheet in section 3.2. And they usually make them pretty easy. Ones that you can just kind of mentally do without a calculator. So I'm kind of thinking off to the side, and add this if you need to, if you can't figure out these logs yet. But remember, we set it equal to a variable, and then we converted it to answer it. 3 to the what power gives me 27? The answer is 3. So this logarithm has an answer of 3. So 1/4 times 3, and then the answer is just 3/4, because we can obviously multiply those together. Okay. All right, let me show you 8, and then see if you can try a couple of these. All right, what kind of property could I use right away? Actually, we could evaluate this right away. You've got options for this one. I could do 4 to the what power is 1/64, go through it, but let's try to use one of our properties. I'll show you another way to do this. Quotient property, U over V. So we can do log base 4 of 1 minus log base 4 of 64. Okay, and then both of these are, maybe you already see the answer. I don't know, but now you're kind of asking yourself, all right, since I don't have any variables in these two spots, maybe I can evaluate this and say 4 to the what power is 0. And for this one, I'm trying to figure out 4 to the what is 64. I can evaluate both of these. 4 to the 0 is 1. 4 to the third power is 64. Okay, so we have 0 minus 3, which is -3. Okay. All right, why don't you try 10? 10's actually a lot like 8. Give that a shot. I'll talk about number 9 in a moment. Pause and try 10. Okay, so here's the quotient rule. Just don't be thrown off by this. Here the base was given. This one, it is given. You just got to know it's E. Okay, so when I've got natural log of 1, it's another way to consider it, log base E. So we're saying E to the what power gives me 1. E to the 0 is 1. Okay, so that has a value of 0. This one you could actually evaluate right now too. I could say E to the x equals this and get 4/3. If or maybe use the power rule like I did. And now I can go off to the side and evaluate this. So I'm asking myself, e to the what power gives me e? Well, bases are the same, so x equals 1. E to the first is equal to e, of course. So we got 0 minus 4/3 times 1. So 0 minus 4/3 is negative 4/3. That's the answer to that one. Now it got a little tricky. There you go. Okay, here's number 9. There's really no property. We can't break this up. We're just going to have to try to evaluate it right away. Unless I want to break this down to, I don't know, 25 times 5. I guess you could try that. But let's go ahead and just set it equal to a variable and try it. 5 to the x equals negative 125. Well, I can't take a positive 5 and raise it to any number and get a negative. That's kind of impossible if we start thinking through it, right? Even if I have a negative exponent, that doesn't make this negative. If I had 5 to the negative third, that's 1 over 5 to the third, or 1/25. That's still positive, and those aren't equal, obviously. So there's no solution. Anytime this argument is negative, it's going to be no solution every time. That's why we say x yesterday always had to be greater than 0 when we did domain problems. So no solution. Arguments must be positive. All right, now this one asks us to go ahead and expand these. We're going to try to expand it as far as we can using those 3 properties on the other side. Sum, difference, and or constant multiples. They just mean if you have a constant, put it out front, right? Power property, we can write as a constant. Okay, so first one's really basic and easy. First of all, you got to realize we have a product, right? 15 times x squared. That's like the u times v, if you will. So we can write that as a sum. Okay. Product to sum. So log base 4 of 15 plus log base 4 of x squared. Okay, and then we got the power property going on. So the 2 is going to come out. So I have log base 4 of 15 plus 2 log base 4 of x. And check to see if you can simplify it. If you got some basic ones like we had up here, log base 3 of 27, we could evaluate it. 4 to the what power gives me 15. It's going to be a decimal. Don't worry about it. You don't have to answer it if it's going to be a decimal. If it's an obvious integer, use it. Problem's done. Okay. Try 12. All right, as I mentioned above, if you see a radical, you're going to want to convert it into exponential form so that you can use the power property. So right away, I did that. When I expanded it, I made it t to the 1/2. Okay, and then put the 1/2 out front, and that's it, as far as we can go. Remember, this is base 10, so 10 to the what power gives me 7. It's going to be a decimal. Don't worry about it. You don't have to continue on. Okay, now 13 actually has an additional step. Let me show you. Right now, the big picture is we see u over v. So let's write it as natural log of u minus the natural log of v. Okay, but now I still see a product, so I can't stop there. I can continue to break this down when I have the u times v, right? So I need to break this up into 2 more logs. So I have natural log of x cubed plus the natural log of y. So this one has 3 logs in the final answer. Okay, so now I have 2 exponents I take care of, and then that'll be it. So 3 natural log of x plus natural log of y minus 4 natural log of z. All right, if you're done writing that down, try number 14.